Okay, in this video, I'm going to teach you about dividing polynomials. Specifically, we're going to use the method of long division. Okay. Before I show you what it looks like with polynomials, I want to take you back to elementary school. Yep, that's right, all the way back to elementary school, and do some long division with just regular numbers. Okay. So most of the time the problem is presented in this format, really because it's easier to type on a typewriter. A computer, it's usually easier to type on a computer when it's straight across like this, but I want you to rewrite it in the long division format. There is something that I just call it the division house. Kind of looks like a L that was knocked over on its side. The first number is going to go on the inside, so we're going to put the 7,531, and the 4, which is our divisor, is going to go on the outside. Okay, and then we go through a series of steps, and it's actually a pattern, and that's really what I want you to catch up on, is this pattern, because we're going to take the same pattern that we used for this problem and apply it to the ones with polynomials in the next example. Instead of dividing 4 into this large number, 7,531, we're just going to look at how many times 4 can divide into this first number of 7. We're going to break it down. We're going to ignore the 531. 4 can divide in there. It can go in there one time. So we're going to put that 1 on top of the division house. Then we are going to multiply. Put a little dot. That dot represents multiplication. 1 times 4. Let's erase that. I'm going to put it directly underneath the 7. Now I still want you to ignore the 531. We are going to do a subtraction problem. Just the 7 take away 4, which is 3. And then we are going to drop the next number, which is a 5. And the whole process starts over. Okay, so we're going to go back up here to 4. How many times does 4 go into 35? This time it would be an 8, because 8 times 4 is 32. We're going to subtract those to get a 3, and we're going to drop this 3 down. And then you hit the repeat button. We're going to do it again. 4 goes into 33. It also goes 8 times. We're going to multiply. 8 times 4 is 32. We're going to subtract to get 1. Last but not least, we're going to drop this other 1 down. 4 goes into 11 2 times. And it looks like this problem is going to have a remainder. 2 times 4 is 8. And then when you subtract 11, take away 8, you have a remainder of 3. Okay? But instead of just saying R3, like maybe you've done in previous classes, we're going to take the remainder and we're going to put it in the numerator with the divisor as the denominator. So we're going to convert it into a fraction. Very much like if you said you had 9 cookies and you wanted to divide them in half, you would have 8 and 1/2, one left over out of the 9 over 2. So this is what your answer is going to look like. 1,882 3/4. So we're going to use this same pattern, except now I'm going to show it to you with polynomials. Okay, so take a look at this problem. This is an actual long division with polynomials, so pay close attention because I'm going to go through those same steps from the previous problem with this problem as well. Okay, the first thing we're going to do is we are just going to focus on the first terms of each of the expressions. We're just going to look at the x and the 7x squared to get us started. Okay, and the question that I have for you is how many times does x go into 7x squared? Okay, if that question is a little hard to understand, then I want you to maybe let's think of this question. What number up here, okay, when you multiply it times x equals 7x squared? Well, if you had 7x, that's the number that would make it work. So 7x times x is 7x squared, because this is our multiplying, except this time we've got to make sure we're multiplying twice because this is a binomial. So it's really like doing the distributive property. It looks a little different than the traditional distributive property, but this is actually what we're doing. So we multiplied the 7x times x to get the 7x squared, and then the 7x times -1, and we're going to line that answer up directly underneath the next term. And then I'm just going to draw a line. This is kind of like my total line. Okay. Now I'm going to subtract. I'm completely ignoring the -8 right now. We're going to do a 2-column subtraction. And I encourage you to circle that subtraction sign out there because it's really easy to forget that you're subtracting. And what I mean by 2-column is that we're going to first subtract this first column, and then we're going to move here and do a subtraction there, still using this same subtraction symbol. The first column is 7x squared minus 7x squared, which is 0, which is great. Okay? And actually, if you're doing long division correctly with polynomials, this first one should always match up to cancel out. So I'm going to go ahead. You don't need to put that 0 here. That would just get in the way. So just cross out that section. And the second column is where you really need to pay attention. This is when it's super easy to forget that you're actually subtracting. It's really easy just to look at these two expressions and say, oh, this is x, take away 7x. But it's actually x, take away -7x. Okay? And if you need to, take a moment and write that off to the side. Like if it's difficult for you to imagine, okay, what does that mean? X, take away -7x. Please write it out horizontally, because sometimes you can just tell better, like, okay, the double negatives is when I need to add. So this is actually going to be an 8x. After we subtract, we're going to drop down, and so we're actually going to drop the 8 and the negative sign that comes with it. And then that whole process starts over. We're going to ask yourself, x goes into 8x how many times? Or another question that I give to my students in my classroom is, if you had a number up here and you multiplied it times x and your answer was 8x, what does that number, what the missing number would need to be? A positive 8. And it's really important that you mark if it's a positive or negative, especially since it's the second answer in this expression. So make sure you mark that it's a positive 8. Then we're going to go through and multiply through twice, except this time I'm going to erase our old ones with the 7x. This time we're multiplying twice with the 8. So we have 8 times x, which is 8x, and 8 times -1, which is -8. Okay, I'm going to draw that total line again. We are now subtracting. Okay, 8x take away 8x. Again, if you're doing this correctly, okay, it's usually going to end up where that first one crosses out. And actually, the second one is about to as well. This is -8 take away -8. So think about that one. If you have -8 and then you take away -8, you have 0. Okay? So this has no remainder. And so where are you going to find your answer? Your answer is all the way up top here, 7x plus 8. All right, guys, let's try one more problem together. Okay, we are going to start this problem off exactly how we started off the previous problem. by just looking at the first term of each expression. So we're just going to look at the 2x and the 2x cubed. And I'm going to use those two terms, and I'm going to ask you the question, what number would we need here so that when we multiplied by 2x, we got 2x cubed? Okay. Hopefully you are thinking what I am writing, an x squared. Okay. Next, you're going to multiply that x squared twice because this is a binomial. So it's really like using the distributive property right there. X squared times 2x is 2x cubed. And then x squared times that 3 is 3x squared. Okay. And notice that our problem is in descending order, and so it's going to kind of work out where our answer is going to work out in descending order. I'll show you on another video when long division doesn't necessarily start in descending order and how to handle that, but that's for another time. So let's continue. Once you have multiplied, I want you to draw this total line, and we're going to subtract. Here, we're going to do that 2-column subtraction. We're first going to subtract the 2x cubed minus 2x cubed, which should cancel out. It usually does. And then we're going to subtract right here the 7x squared. Now don't forget, this is the one where it's really easy to forget you're subtracting. When your eyes first see the 7x squared and the 3x squared, it's really easy to think, oh, 10x squared. No, not this time. We're subtracting, and so this is actually a 4x squared. I'm going to just extend that line a little bit and drop down this positive 2x. Then the whole cycle repeats again. Go back up to the 2x. How many times does 2x go into 4x squared? Or if that's kind of hard to think about, turn it into a multiplication problem. What number, when you multiply times 2x, would give you 4x squared? Okay, that would be another 2x. And specifically, it would be a positive 2x. So you do need to mark a positive 2x there. And now we're ready to multiply. 2x times 2x is 4x squared. Okay. And then the 2x times the 3 is positive 6x. Okay. All right, here we go with that double column subtraction. 4x squared minus 4x squared will cancel. Goodbye. And then 2x minus 6x. This is going to be a negative 4x. All right. Almost done. We have one more number to drop down. This is going to do a little curvy line here. This is going to be a positive 9. Okay. Again, ask yourself that question. Okay, what number, when we multiply times 2x, gives you negative 4x? Okay, that would be a negative 2. We're going to multiply twice. This would be a negative 4x minus 6. Okay. Now be really careful here. We're subtracting the negative 4x. Take away negative 4x cancels. So that goes. Okay. This is where you really need to be careful because, again, our eyes, our brain plays tricks on us. You could look at this 9 and the negative 6 and say, oh, 3. So if you wrote 3, that is not the correct answer. I'm sorry. This is 9 take away negative 6. And take a moment, if you need to write it out horizontally, 9 take away negative 6, to see that those two negatives are actually a positive. Okay, this is positive 15. Now this is the first time we have a remainder, but remember back to the first example of just the basic elementary school long division. We're going to take this remainder and put the remainder in the numerator and our divisor in the denominator. So here's what we're going to do. We first need to mark if this is a positive 15 or negative 15, and it is a positive 15, so because it's a positive, we're going to put a plus sign, and the 15 stays in the numerator, and then the 2x plus 3 goes in the denominator. So it kind of makes your problem look a little ugly, it looks unbalanced, and it looks not right, but it is right, and this is the best answer for this problem. Okay, your turn. I want you to pause the video and try some of these on your own.